A moving ball has kinetic energy in it. A moving ball can transfer kinetic energy from one place to another place. This can be seen here, where I throw a ball from this place to this place, and in doing so, I've transferred kinetic energy.
But do you always need to throw something from one place to another in order to transfer energy?
So, what I have here is a demonstration to show how you can transfer energy from one place to another place without actually sending something from this place to that place. So this is similar to the thing explained in the last module, where I had shown you how a vibrating object produces sound and how we actually get the disturbance in air due to a vibrating object. So let's say these balls represent some air column, and here you have the listener or his ear, and here you have the vibrating object. And let's say this is one of the particles, so obviously there will be many more particles all around, but I'm just showing you a few particles due to the limited number of balls that I have here. But yeah, the point is, this is one of the balls that this is one of the air particles. This represents one of the air particles that is adjacent to the vibrating object. So let's see what happens when the object vibrates and hits one of such air particles. Just watch carefully now. Yeah, so there you could see when this vibrating object hit this air particle, it moved and it hit other air particles present in this air column. But if you notice here, energy was transferred, right? Energy was transferred from the vibrating object to an air particle around it, to which then transferred the energy to the next air particle, and so on and so forth. And then this last air particle got that energy and it traveled, and it gained that energy. So energy was transferred from this place to that place, but nothing actually moved from this place to that place. This ball, okay, stayed here locally, and that ball stayed in that place locally. It moved, but not too much. Did not cover the whole distance. It moved only in that region, and that is one way by which you can transfer energy from one place to another without actually physically moving anything from one place to another directly. So obviously locally there is motion, but there is no motion from this place to that place. Such a transfer of energy is called a wave. So in the um, in one of the next videos you'll see the definition of wave as a disturbance. So that is one way of describing a wave. But another way of describing a wave could be a method of actually transferring energy from one place to another without actually physically sending something over that distance. So now I hope you got this idea. Now I'd like to one last note is that many of you were thinking that uh, when something vibrates, it actually pushes air and that air travels directly to your ear. That is not what is happening. So I'll just quickly recapitulate what actually happens. Is if something is vibrating, so let me just, if this is some air column, and when something sits in, when the vibrating object actually vibrates, it actually, so there's some, so these air molecules are actually spread out. So it first of all pushes these objects, which, okay, and then sets them in oscillation, which then push them and set them in oscillation. Why do they oscillate? Well, because when they move forward and when they move forward, there's some empty space, and to fill up that empty space, they move backwards. So that was described in the last video, and that is the mechanism that was followed, and that is the way energy is transferred. Nothing moves from here to there. That was a very simple example. And in this, one thing I'd like to show you is that when these objects are oscillating, these air particles are oscillating back and forth in such kind of a wave, the wave is traveling in that direction, right? The transfer of energy is in that direction. So it moves from this place to that place, the energy. But the oscillation and the oscillation of those individual particles, if you focus on any one particle, is in this direction. and if you see, this oscillation is parallel to the direction in which energy is being transferred. Such a wave is called a longitudinal wave, in which actually the individual particles of the medium through which the wave is traveling oscillate along the direction of the of the wave itself, or in the direction in which the energy is moving. Now there's another type of wave which we'll see now. So here I have a skipping rope with me. I can tie one end of the skipping rope to a pole and take the other end of the skipping rope and give it a flick. When I do so, a wave travels from one end of the rope to the other end. You can see there that here in slow motion. Now let's try something different. Let me take some electrical tape and mark a point on the skipping rope. I'll just mark this point here on the skipping rope with the electrical tape so that it easy for our eyes to notice it. This point. Now I'll go back and tie one end of the rope to the pole and take the other end and give it a flick. So it's this point right there. Now when I give it a flick, let's see that in slow motion we get a wave as usual, and let us just zoom in at that part and see what's happening. There you go. So let's see what actually is happening there. Here, so the blue point is actually moving only vertically up and down and does not move back and forth. So you can use the tree in the background to confirm this fact. So a wave in which any point oscillates up and down or perpendicular to the direction of motion of the wave, that wave is called a transverse wave. Another example of a transverse wave is this.